Hello everyone, December the 6th. Alright, a little bit late today because I have to finish the book and then return to the library before basically today. Alright, another easy one, so let's get it fast. Hersey wants to save money for his first car. He puts money in the LeetCode bank every day. He starts by putting $1 on Monday, the first day. Every day from Tuesday to Sunday, he put one more than the day before. On every subsequent Monday, he'll put one more than the previous Monday. Given n, return the total amount of money he will have LeetCode bank at the end of nth day. Okay, I think fairly straightforward logic. So basically, so each week is going to be 1, 2, 3, 4, 5, 6, 7, right? And the second week will be 2, 3, 4, 5, 6, 7, 8, and then so on and so forth. And depending on n, right? Depending on n. So each one is going to be one more than the previous. So this is going to be the base. What's the base? 28? Yeah, the base is 28. So this is 28 plus 7, because everyone is one more than before, so it's 20 plus 7. And the third week is 28 plus, basically plus 7 times the quotient, right? So 28, I shouldn't say 28. The base, 28 is the base, right? 28 is the base. So whatever this plus 7 times the quotient. And what we need is find out but it's a total, right? It's the total. So what we have is based on the Q. So n, divided by 7. Whatever it is, it's going to be 28. Because each one, that's 0. Right, so 28 times 1 plus Q plus 7Q. That's the plus. If I have, like, say, Q equal to 2, right? So it'll be 2 full weeks. So it will be, if it's 2 full weeks, shouldn't it just be times Q? Yeah, it's just times Q. Right, if 1 full week, wait, hold a second. No. There's a second week, it's a third week, it's a 0th week, right? It's the first week. Second week will be 28 plus 7 times Q. And if you add them together, right, if you add them together, it's 28 times Q plus 1 plus, 0, 7 times 7 plus 7 times 2 plus plus 7Q. Right, that's what this Q is. If your Q is 0, well, we don't consider Q as 0. We consider the full weeks, right? If your Q is 1, well, 1 full week. Right, so just 7 times 1 plus 2 plus all the way to Q, right? So 28 times Q plus 1, 7 times Q plus 1, Q divided by 2. So, if Q is equal to 1, that's not right. Q equal to 1, we just have the first one. Yeah, I think it should be 28 times Q, not Q plus 1. I think it's just times Q. Right? So if Q is 1, then we have 28 and plus 7. Right? Q is 1, 28 plus 7. Q if it's 2, we have 2 full weeks. Then 28 times 2. And then Q is 2 is going to be 3 times 7 because I have, 3 times 7. That's not right. Because this is 0, right? This is 0. So Q equals 1. This should be 0. So this should be Q minus 1. All right, it should be Q minus 1. Should be Q minus 1. So 1 plus all the way to this. So it should be Q minus 1. All right, therefore, if Q is equal to 1, so we have 1 week is 28. If we have 2 weeks, 28 times 2, and then it's going to be 7. Yeah, so it'll be this, right? That's the Q. And then we have a quotient, right? We have a quotient. And then we have quotient, we have a remainder. So we have R. So this R will be interesting, right? This R. Because R, depending on R is 1, we do this, right? R is 2, 3, 4, 5, 6. Because R is not 7, right? R is this. So R is going to be 1 plus 2 plus 2R, right? Which is R plus 1 times R divided by 2. So that's that. And then plus, because everything has to be 7 times, well, depending on the Q, that should be Q plus 1. Because each round we have Q. Each round we have a Q. Right? Because this, if we end up here, then no, there's 7Q. There's 7Q plus 7Q. And if it's R, let's say is 2, right? R is 2, which means we do this, and I'll have 2 more. So extra should be 5. So we do 2 is here. So it's 3, right? 3 plus, it's not 7. No. That's not right. It should be R times Q. However many, each one, right? Each one we plus 1, right? And then you do this, will be plus 2, right? Be plus 3, so depending, that's the Q. So RQ, so Q is 1, R is 2, so 3 plus 2 is 5. So yeah, that's going to be the answer. We can try 20, okay? So 20 divided by 7 is 2. 20 mod 7 is 6. Okay, so Q is equal to 2, R is equal to 6. So we do 28 times 2 plus 7 plus 6. 6 times 7 divided by 2 plus 6 times 2. So this is 56 plus 7 plus, that's 21 plus 12. What was that? That's 63. 84, 96. Yep, I think that's it. Int Q is n divided by 7. Int R is equal to n mod 7. Right? And now we return 28 times Q plus 7 times Q minus 1 times Q divided by 2 plus R times 1 plus R divided by 2 plus r times q. All right, let's see if it's correct. $30, $40, $50, $60, $70, $80, $90, $100, $1,000. Of course, we do 1, 2, 3. Very comprehensive. Yep, this looks right. Some analysis. I was going to do Vim, but I can. I mean, why not? It works. Right? It works. Okay. Decremental string concatenation. You're given zero-indexed array words containing n strings. Let's define a join operation, join xy between two strings, x and y, as concatenating them into xy. However, if the last character of x is equal to the first character of y, one of them is deleted. For example, join ABBA becomes ABA. Join AB and CD becomes BC, okay? You are to perform n-1 join operations. Let str0 equals words 0, starting from I up to n-1 for the ith operation. For the ith operation, you can do one of the following. Make stri equals make stri equals stri minus 1 and then words I. Make stri it's also either left to right or right to left. Your task is to minimize the length of the last one. Okay, so in this case, we start with AA, right? So we need to go str1. We shall do this so we can remove 1. And we shall do this so it will be 4. This we just do, it will be 2. This will do AA and C. There's no way, but we can remove 1, so it'll be 1, 2, 3, 4, 5, 6. 1,000. Okay. What do you think? What do I think? So the words is gonna be something, 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 something. Doesn't matter, right? Doesn't matter what. And then we start from this, and at each step, right? At each step, we have to join this, but we can do this join, or we can do the other way join. And the most of the length is 50,000, so that's not really that much. So maybe we can DP, right? So basically, we have an I, right? We have the I, and I have the previous state. And we say, that doesn't sound right. We shall do, hold on, let me think. Because what we want to say is starting from this. Now, starting from this, what is the best way going forward, right? Is greedy gonna work? Like every time you always ensure that it's gonna remove. Because if it cannot remove, oh, it still matters, right? If you cannot remove, depending on where you put, it might affect future. If I have done the remaining, would that be? Let me think. If I join something and then this to join with the remaining, yeah, that's not. I remember each step you can only delete one. Okay, each step you can delete only one. So the goal should be try to delete as much as possible, right? Delete as much as possible. And all the letters in the middle doesn't really work. So we can simplify this whole problem because each one basically we have a start and end, right? We have S something end, and we'll have a star something end, star something end, right? Basically that's all the way down. And the goal is to concatenate everyone and then such that we can find the same ones. Hold on. So the idea, so I want to go try the greedy. So the greedy says, if I have an opportunity, but then you can have two different opportunities, right? Like if one side can match, then I just match it. What if I don't match? Exactly. What if I don't match? So we're saying, if I have a chance, right, A, B, right, instead of we matching these, we don't match, we become A, B, A. So what's the benefit of doing that? Well, the benefit of doing that, you expose this, right? It's probably not. Let's do a CA. Okay, how about CA? Right, CA. Instead of matching this, we don't match. So we have something we can match, then we don't match, and the ending is this gets exposed again, right? This one gets exposed, and the one can match. This one also get exposed, right? So the possible to match gets exposed, right? And we say if in the future we match, then we have the opportunity to reduce 2 times, right? If we say we have another A and AA, if we have another AA, right? If I do this AA, we can remove this one. I mean, I think maybe say AE, AD, DA. How about this? Right? So if I don't match, I can go this, so become E, and I can go this, become D, DBCA, right? If I match them, become CAB, and nothing matches. Actually no, because I can do AE here, and then do DA here. Yeah, that's bigger, right? So always match is not the way. Okay, always match is not the way. Oh, because it could be a single, so the ones in the center also matters, because you can expose new ones. Nah, I don't think analysis should work. I think this most likely should be a DP problem. But the DP problem, what is the... Because the question we should ask is the current string, right? Given the current string, yeah, given, so how about maybe DP index and then str, the current str. So it's starting from the index with the current str. What is, right? What is the final result? The str could be huge varieties of str. You sure that's the way to go? Because we have the current, we have the state, right? And then we are in the current one, so we can, but you're iterating through all different varieties. So each one has 2, so you're going through 2 to the 1000. I don't think that's gonna work. I don't think that's gonna work. And I don't see, let's say, the optimal solution for the remaining will be also optimal for this at the start. Yeah, because I already proved it. I showed an example that optimal so far doesn't really mean optimal down the line. Because you're burying the possibilities for other to match. I mean, after each operation, you expose new things, right, to match. But still, what's no idea? Oh. I think it's a different type of DP, maybe. Ending. Remember the string. Oh, I shouldn't say the string. What if AC match with C? Right? You cancel this, but it remains. So the ones inside doesn't get exposed. So like, start and end. Yeah, the ones inside. So I'd be like, it's A something something C, right? And then you meet with C. And you decide to put it here. Then you basically just replace it, right? This one just doesn't exist, but the inside is still protected. So which means I can say I'm at index, right? And then the previous start, the previous left, and the previous right. Given that, what will be the best that I do? So with this, it's just 1000 times 26 times 26, right? So the question is, well, should also is dp0, just empty and empty. That's what we're starting with, right? That's what we're starting with. And for the current thing, the current string, I have a start and have an end. Then I can decide to either go with this, because that's the start, this is the end, this is the left and right, okay? So I have a left and right. I can say, okay, mine I'm gonna do the current my left and my right, and then if they then I have a new left and right, and then we'll push this to the end, and eventually they will return a value, right? Or I can do the other way. Just be careful with, just be careful with but do we need a length going on? We do need a length. So we have a left and right, and we need a length. Oh, the length. Or like additional length will be added to this. Yeah, so dp this is given previous start and end as this, and I'm gonna go from this towards the end. What is the additional length that we're gonna add to this thing? Additional length to the current thing. So I don't care. Yeah, we don't really care about the previous length, right? What we care about is the additional length that we're gonna add to the original, right? So the original is this. We have a left and right, right? We have a left and right, and now we say I have a left and right, and the current words, right? Words index is 0. Okay, so I say I'll put in here, right? This is one way, and this will add additional length. So we don't care about this. So if limit this will be +1, If we don't eliminate, it will be +2, right? And then we have a new thing, right? New thing, left and right, and then we push down and see what's the additional length for this, right? What's the additional length for this? So the remaining, so this additional length will add to it. And then this will return the additional length. And then with the current additional length, so given the previous, right, we do this, we add additional length. And we just go and we have additional, so put us together will be the total additional length. All right, I'm not gonna code this in this because I just find it pretty repulsive. No. Because I have to do a, oh, really? You're just gonna give up? You're just gonna give up, man? Is that what this is? Huh? Is that what this is? Come on. That's not who you are. You don't give up. You don't give up. Because we're just gonna do this. We know. We know exactly what to do. Right? It's just, you know, it's just a index. Oh my god. So you do index first, right? And each one is yeah, it's fine, it's fine. So we're gonna say int this memo, okay? Which is fine. And then we can do memo equal to new int. This is gonna be words.length, right? Yeah, and this is gonna be 26. This is gonna be 26. And we're gonna define a function, private int dp. We're gonna do index, right? And we can say int l, int r. It's fine, right? It's fine. It's just char. And then this one shall return dp start from 0 and -1, right? Can we do that? Yeah, just nothing is the same, so we just go ahead. But then you'll have -1, which is not good, right? So maybe we need to do 27. So we need to, because as a start. Oh, that's not right. That's not right. We'll start with 1. Just realized 1 with this shall be, yeah, because the first one is done. Right, the first one is done already. It's AA. It's the first one, right? So we given this, we want to know what's the, starting from this, what the previous is this. What is the smallest additional we're gonna add to it? Right? What's the smallest additional we're gonna add to it? So what we're gonna have, this is just gonna be words 0, right? Because I have at least 1. Words 0 dot char at 0 minus 6, 97, right? It's 97. Hold on, let me double check. Is it 97? Yeah, 97. So this will be minus 97. This one will be words 0, right? Dot char at words 0 dot size length -1. This is the last one. minus 97. So left and right. Okay, so this is left and right. So this is the total. Okay, this is the total additional, and we have original plus the total additional. Okay, so that's the answer. And for this, we also need string words. So we can do this. This dot words equals words. Okay. Okay, so now we have this. We have the index of the left and right. All we want to do is additional. Okay, what is additional? Okay, so first of all, this has to be integer. Sorry, it has to be integer. Okay, and then we say if, right, memo index left right is not equal to null, and return memo index L and R. Okay. Otherwise, it does not exist. Right. Otherwise, it does not exist. What we do is going to be check the memo. So we have two ways to do it, right? So we say we're gonna append words index 0 to R. Remember, it's additional, right? We only concern the additional that's going to be added to it. So if words index, right, dot char at 0 minus 97 is equal to R, right? So we match. If that's the case, then we should say int possibility 1. Okay, possibility 1. So if they match, then the possibility is going to be, then possibility 1 shall equal to 1. Right, we added 1 additional because one of them gets deleted. Right, we have left and right, and a words index we put it here, and then this one gets deleted. Right, so we basically add 1 additional, and then we're gonna say dp index plus 1. Left didn't change. Right, our right is gonna be words index dot char at, oh lordy, char at words index, dear me, string w equal to words index. Okay, so all the words index can change. Words index is okay, so this is w. Okay, so next dot. Right, so I have words as this, version 1, this, and then this chart was dot length minus 1. This is the last one, minus 97. Right, because we append words 0 to R, and then they cancel out, so it's +1, right? Else if they do not equal, then position possible 1 is going to be 2, right? Plus, so it's the same thing. We yank this and I paste it. That's exactly the same thing. Which I think I can simplify it equal to, so let's say we paste this, right? And then we plus w.char at 0. Okay, minus 97, is it equal to R? If it's equal, would be 1. If it's not equal, would be 2. Right? That's 1. Left doesn't change, your right becomes the current was right. Or append words index -1, right? Append this to left. So int possibility 2 is dp index +1. Left changes. That's going to be word w.char at 0. Okay, minus 97. Doesn't matter. Right? So it doesn't matter. And then shit. No, we'll deal with that later. So, and then this is R, right? R doesn't change, right? R does not change because we handle the left, right? The left, and then plus, say w.char at w.length -1. Minus 97. Nope. We're gonna do here minus 97. Right, this is the and. Right, this is the and. So and, so this is equal to left. If it's equal, then we do 1. Otherwise, we do 2. All right. So this is not complete because it is possible that additional is 0 if it's yeah, if it's 1, right? If it's 1, so it also depends on the length. So we should also say int, right, w length. No, I think I can just do it. Okay, let's do this. Char s w.char at 0. Okay. Char and equals w.char at w.length -1. Minus 97. Yeah, it's just, it's not a char. It's not a char, just int. And this is gonna be minus 97 as well, and then we're gonna be to char. What did be to char? I have to do it again. This is int. Okay. And then position 1, so we can undo this entire thing. Oh no, this one. Right, right shall be and. Right, and this is the same. This is the start. Right, if the start is equal to, I'm gonna do this again. Right, so we append the new word start to the right. Right, if the start is equal, then additional, that should be w.length -1. right? This should be w.length. Because it depends if w is 1. Its only length is 1. Right? And oh, that's not right. No, it's right. It's right. Additional. We're talking about additional. If s is not equal to r, so the start is not equal to right, then the additional we add is the whole thing. Right? Otherwise, it's this. So based on this, we can change this one as well. So this is gonna be the append to this. So new one will be the start. Right? Doesn't matter. New one will be the start. And then this is going to be the end, right? If the end is equal to the left, and this is going to be w.length minus 1, otherwise it's going to be w.length. So I have two possibilities, right? It's the additional, right? The additional, then we're going to return the minimum of the two, position 1 and position 2, right? So we can also make a note, dp returns the minimum, the mean additional, okay, additional chars added to the previous string, starting with L and ending with R. That's what it is. That's what it is. And we don't do this because we have to also do memo index L and R. It's good because we didn't change L and R, so we don't have to worry about making the same mistake. So I'm going to return memo index, right? L and R. Okay, so now what we need to do is find the edge case. What is the edge case? Well, the edge case is if index is equal to words.length or return 0, because we go out, right? There's no additional. Otherwise we do this, and all right, let's give this a shot. Just this. Let's see if this one works. Well, this one works. How about all of them? Do they work? The last one didn't work. My answer is 5, but actually it should be 6. No worries. No worries. Okay, let's take a look. So string this words equal to that's not right. This is Python. New string what's that? C AVA. This is minimize words. Okay, just kind of let's analyze it. I don't think this is too hard to analyze with this. Right, so we start with AAA. Oh, I knew it. Words 0.length. Hold on. I would like to make some change. So int s equal to words. Basically, let's copy this. Find the W. F7. We'll see this and paste this. And int and will equal to, come down. Right, this is VF7 again, see this, and go to the end, paste this, right, and here is going to be start, end, okay, and this is not 2, this is words 0 dot. It would be easier here. Hold on. String w equal to words 0, right? And we're gonna do all the words be w, right? Next w, next w, next w dot length. Okay, so let's do this. Okay, submit it. There we go. Yeah, use DP where DP index left, right represents the minimum additional letter added to the string when incorporating words index with the previous string, starting with left and ending with right. Right, in the implementation, left and right is replaced with the index form of chars A to Z, where char A is 0 and char Z is 25. For each words index, there are 2 ways, right, to be appended to the previous str, either at the front or at the end, depending on whether there are matches. The additional letters added to the str will change. ON times 26 times 26. And we have a pretty good runtime. I'm pretty proud. This is I don't think this is like, let's say, an easy, really easy problem. I think it's pretty complex. But it's a pretty basic DP, that's for sure. Oh, 30. I don't know why you do 30. Yeah. Yeah, similar idea. All right, good. But that's it for today. All right, that's for